5 sounds good.
No, what the heck?
Most reasonable answer.
Hacker.
Alright, so if we are going to find the volume of this, so this is 3-dimensional. We were finding the area of the curve using rectangles. We're going to find the volume. We are not going to do rectangles. We are going to do cylinders. Okay, so the first cylinder is like that, and you can imagine you see what I just took out? It's a chunk.
Oh,
If you can't visualize that,
Photons.
we need the power at Hanoi to help us. If we add them up, you have the volume of a sphere, if that was spherical. Does that make sense? So that's the kind of cylinder. The area of the base, so pi r squared times the height, and that's the volume of that cylinder in every cylinder. So let's chop it up. Let's just find this hemisphere or half a sphere and then double it. So let's go by 1, 2, 3, 4. Let's go up by 1 on the right side. Okay, so what is the volume of that first cylinder? Yes. Thank you.
How is that one the same as that?
Because it's coming out at a sphere, so take it and go. There it is.
Why'd you turn it?
Easier to look at.
You want it more like, does that make more sense?
Doesn't matter.
Sure.
The picture.
Wait,
That would make more sense, but it still, think through the power of Hanoi.
wait, no, because that's not a circle.
Right, it's a sphere,
Okay.
so it's a cylinder. Okay, so how do I find the volume of that cylinder? Well, it's pi r squared h. What's my height of my cylinder? 1. It's just 1. So the volume of that one would be pi r squared times 1. What's my radius?
5.
It's that distance right there. That's 5. So my first cylinder is 25 pi. Okay, second cylinder.
I think this is everywhere.
No, this is LRAM.
That's what I said.
No, it's not.
Did you really?
That's what I said.
We'll have to check the footage.
You did
It's
say
heavy,
that.
yeah. So volume of that cylinder is pi r squared h. So it'd be pi r squared. My h is always going to be 1 in this case. The height of our cylinder is 1. My r is a little less than 5, right? What should we say? 4.5? Color good?
Yeah.
What happens when we actually have like a problem like this and we have to actually find it?
Good question. And this would
Similar
apply.
to-
We actually do have to find it.
Similar triangles.
No? Alright, so what I would do is, we need to know what this function is up here. So
It's a parabola.
it's actually just a semicircle, right? With a radius of 5. So if it was a circle with a radius of 5, it'd be x squared plus y squared equals 25, right?
Yeah.
Because the center's at 0, 0.
So just the x
So I could solve for y, x squared, or y squared equals 25 minus x squared. So y is plus or minus the square root of 25 minus x squared. We could just use the top one to find a radius. The bottom one would be this semicircle. We're just going to use the top one. So we can find out this height by plugging in 1. So
Square root of 25.
square root of 25 minus 1 squared, so square root of 24. Squared
That's
That's
is
just 24.
24 pi. Nice mental math there.
Yeah.
Got you.
Alright, so once you try to find the volume of the entire sphere, so you have 1, 2, 3 more cylinders, add up, and then double it. See if you can get that. For the entire sphere?
Yes.
Sure. Yeah.
What'd you, how did you add 2 and get 190?
That's
times
times 2.
Because if we just found this hemisphere, we doubled it.
Yup.
Yeah.
I don't know how
I thought it was x squared over 195. I was like, what is it?
Alright, so do you think what we found is an overestimate or an underestimate of the actual volume of this sphere?
Overestimate.
So it's an overestimate because
Because all those
our
extra
cylinders go
spaces.
outside the boundaries, right?
Yes. And then we multiplied it by 2, so that's even more.
We need to do
So if we did
MR.
LR and RR, we would probably get a closer
You're
estimate.
saying if you do LR on this side and maybe a,
RR on that side.
well, actually the LR will
Just do MR.
be outside and this side, right? So it might actually undo each other.
Yes,
So we need to calculate the other side now.
but with the other
Well,
R.
you didn't do the first side. So.
We got you.
What is it that?
I guess it was all in your head, right?
Yeah, I didn't mention that.
It worked.
Okay, so if we wanted to use our calculator, the RAM program, you can do the RAM program on this one, okay? So, before we do that, let's look at RAM over here. Okay, so if we were doing RAM on our calculator here, what are the inputs? Go ahead and bring up the program. Can they ask you? Equation, and it's negative x squared plus 4x, and then they ask you A. So for this problem it would be 0, and then B would be 4, and then the number of subintervals, right? That's what it asks us?
Yeah.
4. I think it's no sub, or yeah, whatever it is.
Number of subs.
It's 4. Okay, so if we were by hand manually find the area of each individual rectangle, we'd have to go base times height, base times height, base times height, base times height. And all of our heights are determined from the equation, but the base, we don't have to multiply, well, we'd have to multiply 1, but the program never asks us for the width of the bases, right? Why doesn't it ask us for that?
It figures it out with the subdivision.
Very good. You tell it how wide each rectangle is when you say how many subintervals. So here, we don't really need to find out when we do our RAM program. It will figure out what the height is every time. So that's not a part of our equation. We just want to go pi r squared, and we don't have to enter in the height because it will figure out the height when we enter in the number of subintervals. So let's figure out the volume. So what is our equation? Well, it's right here, right? Find the volume as pi r squared h, but we're not going to do h because it will figure it out once we enter in. So all we really want to do is pi r squared. And what's our radius again?
5.
Well, it changes all the time. What's a radius? How do I find my radius every time?
With the x squared. Y equals the square
Right
root
here,
of
right? That's my radius. So my equation is pi times the square root of 25 minus x squared, or it's just pi times 25 minus x squared. So type that into for the equation.
Negative 5.
0.
We can go negative 5 to 5, or we can go 0 to 5 and double it. Might as well go negative 5.
And then 10. Yeah. If we do every one.
Subintervals, we would do 10, right? If you go from negative 5 to 5.
And then should we ram, trap, simp, or quit?
What's the one so far?
One answer.
Well, what's LRAM give us?
518.36.
Oh, so it's not just the pi.
518.
Divided by pi.
That sounds like a lot.
Oh,
It might be different. What, did we get 190 pi? Is that what we got for an answer or no?
Divided by pi, it's 165 pi.
Okay, so it did. Well,
So, like,
why is our answer different? We've already talked about it.
Because we suck.
Overestimation.
It's an over, yeah, so we did this and doubled it, and the calculator did LRAM the whole time. So, well, LRAM here would be an underestimate,
it
underestimate,
evens out.
underestimate, underestimate.
But not exactly.
Right, so it kind of evens out, right? So what do you think is more accurate, 190 pi or,
The other one.
the calculator is more accurate, right?
Whatever the calculator.
Alright, so let's increase our subinterval to like 100.
Oh, it'll be more accurate now.
There you go.
But then we
I
have,
bet you it's pretty close to what the
do
answer
we
is.
have to retake it?
5.3.
523.54.
5.4. Or 5.5, sorry.
Alright, so let's just check our answer with geometric methods. Everybody knows the volume of a sphere is?
4/3 pi r
Well,
cubed.
there's pi.
Attaboy.
Oh,
Volume and girl, whoever said it, I don't know. Who else knew it? Like that a girl. The volume is 4/3 pi r cubed. My radius is 5. Do some math. Give me a decimal. See how. Be curious to see how close we got.
Five 23..
5987756.
309.
That's pretty close, huh? Okay, so probably the most difficult part is understanding this is what your equation is, right? Figuring out what the equation is. So when you're finding the volume of this, all you're looking for in the equation is the cross-sectional area. Don't incorporate the height of your cylinders. Just figure out what the cross-sectional area is, and that's what goes with it. I think that's it.